Welcome to my video on volume of square pyramids and cones. So recall that volume is the amount a container can hold. So we use the phrase fill them up. Okay, so volume talks about the inside. So we might say hold or contain or inside, or we might say fill to talk about the volume. So this is a net of a square pyramid, so opened up, and you can see that a square base pyramid is made up of 4 triangles and 1 square base. Now, if you look at the picture over here, you can see that when this is folded up, this will be on the side. So this is actually called a slanted height over here. Okay. And we'll label it right here. So next to the 6 centimeters here, we'll say slanted height. Now, this 4 is not going to be the B. This 4 is actually a side. And I'm going to tell you how we would actually calculate the base of a square pyramid in just a second. So put an S here for side. The 4 represents these sides. So all the sides would be 4 here because this is a square. And it's pointing to both of these sides as 4. Okay, so the volume formula, and this is on your formula sheet as well, is V equals 1/3 base times height. Okay? And the base is going to represent the area of this square right here. Okay? So it's similar to a rectangular prism in that we have length times width times height. Okay? We have length here and width here, so we're going to use that as the base, and then we're going to multiply it by the height. So where does the 1/3 come in? We're going to talk about that down below. So let's look down below here, and we're going to name the different parts. So the B represents the area of the base. If the base is a square, use capital B equals S squared. So that picture above, the base was 4, so we would have to do 4 squared, or 4 times 4, to get the base. So that base up above of that net would have been 16. Okay, so they won't typically tell you what the base is in the picture. You're going to have to find the base by calculating the area of the square. H represents the height from the base of the pyramid to the apex or top. And this right here, this is the apex. So let's draw an arrow and label that the apex. L is on the outside of the pyramid, so right here, and represents the slanted height. For pyramids, you are finding 1/3 the volume of a rectangular prism with the same base and height. So remember, rectangular prism is length times width times height. Well, the base is the length times width because you're doing S squared, and then you're multiplying by the height. But we have to take 1/3 because it's a pyramid is 1/3 of that of a rectangular prism. So now let's calculate the volumes of the square base pyramids below. So you notice here we're looking for a height from the formula, and we're looking for a base. So I look right here, here's my dotted line. It's not at a slant, it's straight up from the middle to the top here. And the height would be 4, so I'm going to put an H here. Now this right here is the side. So we're going to have to calculate the base because we don't know what big B is. But remember, if it's a square-based pyramid, then the base is S squared. So the side here is 3, so we're going to write big B equals 3 squared because that's what the side is. And the big base is 9. Now, we said the height was 4, so we're just going to write that right here. So h equals 4, and I'm going to box this in. These are the two pieces of information that I need to calculate the volume. So V equals 1/3 times big B times h. So we're going to do 1/3 times 9, because that was the area of the base. That was 3 squared. And the height, we said, was 4. So there's two ways you can calculate this. You can do 1 divided by 3 times 9 times 4. Or you could do 9 times 4 and then divide by 3 at the end, because multiplying by 1/3 is the same as dividing by 3. I don't care what method you use as long as you calculate the volume correctly. So we would get 12 inches cubed. Remember, the volume label is inches to the 3rd power, or inches cubed. Okay, number 2. I notice now that I have a slanted height, which means I don't have the actual height from here, and put a dotted line here. And then put a dotted line here. Okay, so I've just turned this into a right triangle because I'm going to use the information I have to calculate the height. So the slanted height represents the hypotenuse of this triangle that I made, and the base of this triangle is from the middle to the edge. So if the whole thing is 37, then what I have to do is take half of 37 to get from here to here. Then I will have the base of the triangle, and then I will be able to use what formula? Good. Pythagorean Theorem is used to find the missing side of a right triangle. So half of 37 is what? Hopefully you were thinking 18.5. We have the hypotenuse, and we're going to call this A. It doesn't matter if I call this A or B. Okay, so we are going to calculate a squared plus b squared equals c squared. Now we're going to replace them with the letters. We don't know a squared. B squared is going to be the base of the triangle here, so we're going to do 18.5 squared. And that's going to equal the hypotenuse, which is 44 squared. Now 18.5 squared is 342.25. And that's going to equal 44 squared, which is 1,936. I'm going to circle my variable, draw my t. Because I want to get the a squared by itself, I have to do the opposite, which is subtract 342.25. From both sides. A squared equals 1,593 and 75 hundredths. And now the last step is I got to get a squared by itself by taking the square root. So the square root of this will tell me what the height is. So a equals 39 and 9/10. So we're going to put that right here. We're going to point to that and say this is 39.9 for the height. And we're going to put an h here for height. So now we have our height, but we still need to calculate the base because we need the base for our formula over here. So we have b equals the side, whoops, let me fix that. I always like to write the formula first. So b equals s squared. So b equals 37 squared. And 37 squared is 1,369. We know that the height we just calculated is 39.9. So now we're going to use that in the formula. So here's the formula. Once again, v equals 1/3 base times height. So we're going to do 1/3 times 1,369 times 39.9. Remember, it doesn't matter if you multiply these two numbers and divide by 3, or do 1 divided by 3 times both of those numbers. And I'm going to round to the nearest tenth, so we get 18,207.7 inches cubed. So before we move on to the back, it's important to know, when you look at a square-base pyramid, are they giving me the actual height, or are they giving me the slanted height? Okay, and the slanted height will be on the side of the triangle, and it will be slanted. So if they give you the slanted height, you have to calculate the real height by using the Pythagorean Theorem. So when you do your classwork, make sure you keep that in mind. Okay, turn the page, and let's look at a cone. A cone is made up of one circle, and I've already got the C there, and a slant height. Whoops. Okay, for this piece right here. Okay, the formula is going to look very familiar if you recall the cylinder formula. So it's 1/3, and we're going to talk about that 1/3 in just a second, times pi times radius squared times height. So if you look at this part right here, this is the volume formula for a cylinder. So why the 1/3? Because a cone is about 1/3 of an actual cylinder. Okay. So let's look at the different letters in the formula. H represents the height of the cone. R represents the radius of the base, which is the circle of the cone. L has the same meaning as it did on the pyramid. L is on the outside, but now this is a cone and represents the slant height, which is right here. And for cones, you are finding 1/3 the volume of a cylinder with the same base and height. Okay, so let's go ahead and calculate these. So look at the first one, and remember, before we look at it, the dotted line down the center, or when you go from the top of the cone to the middle of the cone like that, and the inside, that's measuring the height here. So in the first one, is that the height or the slanted height? That is the height, so let's put an H here. And what does the 2 represent? It goes halfway across the circle, so that would be the radius. So now I have just what I need. So write the formula. Volume equals 1/3 pi r squared h. So we're going to do 1 divided by 3 times 3.14 for pi. The radius is 2, so we're going to write 2 squared. And the height is 7, so we're going to write 7. Now, once again, you can do 1 divided by 3 times 3.14 times 2 squared times 7 and hit equals, or you could do 3.14 times 2 squared times 7, hit equals, and then divide by 3. Either way, you're going to get the same thing. And we're going to round to the nearest tenth, which would be 29.3 miles cubed. Not sure why they used miles here, because you wouldn't have a cone that was 2 miles long and had a height of 7. But whatever, we'll go with it. Okay, number 4. Okay, we have the measurement here. Is that the height? It sure is. It's not the slanted height, it's the real height. But notice down here, it goes all the way across. So if it goes all the way across, that is the diameter. But for the formula, we need the radius. So what's half of 18? Good. Half of 18 is 9, so the radius would be 9. Now I have h is 18, r is 9. Let's do the formula. V equals 1/3 times pi times radius squared times height. So we got 1/3 times 3.14 times 9 squared times 18. Okay, once again, there's 2 ways to do this. I'm not going to go over both ways. So my calculator said this, so I better review rounding. I didn't show you the rounding on the last example, but I will show you here. If we're rounding to the nearest tenth, underline the tenths, look to the right. If it's 5 or above, give it a shove. If it's 4 or below, let it go. So we're going to let it go. And since it's 0.0, we're not going to write 1,526.0. We're just going to leave that 0.0 off and write miles cubed. And this is a 1 here. It got cut off when I circled it. So that is 1,526 miles cubed. Okay, last example. So look at this. Is this the real height or the slanted height? And you can clearly see it's a slanted height because it's going on an angle here. So this is going to be my hypotenuse. This time I know what the base is. It's 5.7 because that's the radius. And so I need to find the actual height. Okay, so I'm going to call this A, and we're going to use the Pythagorean Theorem. So A squared plus B squared equals C squared. We don't know A squared, so we're going to write A squared. But we do know that B is 5.7, so we're going to do 5.7 squared equals C squared, which is 12.6 squared. Okay, now I'm going to calculate what both of those are. So 5.7 squared is 32 and 49 hundredths. Make sure you write 32 and 49 hundredths. It's very difficult to write this with this pen here. And then 12.6 squared is 158 and 76 hundredths. So now I want to get A squared by itself, so circle the variable, draw RT. So we're going to do the opposite of adding, which is subtracting 32 and 49 hundredths. So we're going to get A squared equals 126 27 hundredths. And now we have to get A squared by itself, so we're going to take the square root. And the square root of that would be 11.2 to the nearest tenth in centimeters. So this right here is 11.2. So now I've got my h is 11.2, and I know my radius, because this only went halfway across the circle, is 5.7. So now we're going to do the volume formula. 1/3 pi r squared h. So we got 1/3 times pi times, the radius is 5.7, so we're going to do 5.7 squared, times the height, which is 11.2. So remember, it doesn't matter which way you calculate it. So we would get 380.86, round to the nearest tenth. Underline, look to the right, 5 or above, give it a shove. So the final answer will be 380 and 9/10 centimeters cubed. Okay, so remember, when we're calculating volume, if they give us a slant height, we have to use the Pythagorean theorem to calculate the real height. So good luck on your classwork and your homework. That concludes our notes. I hope you have a great day.